Shri Gurubhyo Namaha. On behalf of all, I like to offer my humble pranams at the lotus feet of Holy Trio. And I also offer my pranams to most revered Swami Nityastananji Maharaj, President of Ramakrishna Math, Basavanagudi, Bengaluru. I warmly welcome our beloved Swami Tatithananji Maharaj, Warden of Sri Ramakrishna Vidyarthi Mandiram, and Swami Anilayanandaji Maharaj, Assistant Warden of Sri Ramakrishna Vidyarthi Mandiram, to ongoing Knowledge is Power lecture series, organized by Sri Ramakrishna Vidyarthi Mandiram, a unit of Ramakrishna Math, Basavanagudi, Bengaluru. Sri Ramakrishna Vidyarthi Mandiram is a modern Gurukula started in 1943 by most revered Swami Jagishanandaji Maharaj. I am so glad to be a part of this organization, which exposes students to the thoughts of Holy Trio, along with the thoughts of many Swamijis, resource persons, scientists, and many other new upcoming avenues. Now, I welcome today's speaker, Mr. Phanindra Mankale, a software development manager in Alexa, NLU, Amazon, to give a talk on machine learning. I'd like to give a small introduction about Mr. Phanindra Mankale. Mr. Phanindra Mankale, sir, is a software development manager at Alexa, NLU, Amazon, India. He completed his BE Computer Science in National Institute of Engineering, University of Mysore. And then he completed his Masters in Computer Science from Westchester University of Pennsylvania, United States. He started his career as a program analyst in Analysis, US Navy. Then he moved on to be a lead software engineer at EIS International Incorporation and later at OneSoft Corporation. Then he became a senior software consultant at ExxonMobil. He contributed as a vice president of engineering in Work Products Incorporated. He served for 11 years as a principal engineer at Banyan Leaf Technologies, Virginia, United States. He joined Amazon as a senior technical program manager in 2014. He returned to India in 2016 to serve his mother country, and now he is a software development manager at Alexa NLU, Amazon, India. He is managing the language engineering team in India for the Alexa, AI, and NU. Previously, he was a senior solutions architect for the Alexa Skill Kit India. He was a consultant for a government agency to develop innovative methods to process images and documents in C#. As a senior consultant for Fortune 5 company, he helped to define .NET architecture for intranet and internet applications. He started a Kannada school for children at Washington, D.C. area in 2007, and it has been successfully running since then. He has a patent pending for electronic discovery. He is an expert in architecting and constructing software solutions and software products for complex business solutions. He is an expert in enterprise content management, e-discovery, and search areas. With this brief introduction, I would like our speaker to acknowledge the audience. Over to you, sir.
आधारं सर्वविद्यानां हयग्रीवं उपास्महे अस्मद्गुरु समारम्भां टीकारुत्पादपञ्चमां श्रीमदाचार्यपर्यन्तां वन्दे गुरुपरम्परां बुद्धिर्बलं शौर्यं निर्भयत्वं विप्रोगतं अजाड्यं वाक्पटुत्वं च गुरु विष्णु गुरुदेवो महेश्वरः गुरु साक्षात् परब्रह्म तस्मै ಶ್ರೀ ಗುರುಭ್ಯೋ ನಮಃ. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಹೇಳ್ದಂಗೆ ನನ್ನ ಹೆಸರು ಫಣೀಂದ್ರ ಅಂತ. ನಾನಿವತ್ತು ನಿಮ್ ಜೊತೆ ಒಂದು ಬಹಳ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಅಥವಾ ಬಹಳ ಒಂಥರ ಉತ್ತಮವಾದಂತ ವಿಷಯದ ಬಗ್ಗೆ ಮಾತಾಡ್ಲಿಕ್ಕೆ ಬಂದಿದ್ದೀನಿ. ಆ ವಿಷಯದ ಹೆಸರು ಮಷೀನ್ ಲರ್ನಿಂಗ್. ನಾನು ಆದಷ್ಟು ಇಂಗ್ಲಿಷಲ್ಲಿ ಮಾತಾಡ್ತಾ ಇರ್ತೀನಿ. ಎಲ್ಲಾದ್ರೂ ನಿಮ್ಗೆ ತೊಂದರೆ ಆದ್ರೆ ಅಥವಾ ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ ದಯವಿಟ್ಟು ನನ್ನ ನಿಲ್ಲಿಸ್ಬಿಟ್ಟು ಕೇಳಿ ಏನು ಕನ್ನಡದಲ್ಲಿ ಏನಿರ್ಬೋದು ಅಂತ. ಆಮೇಲೆ ನಾನು ನಿಮ್ಗೆ ಪ್ರಶ್ನೆಗಳನ್ನ ಕೇಳ್ತೀನಿ, ನೀವು ಉತ್ತರ ಕೊಡಿ. ಈ ಮಷೀನ್ ಲರ್ನಿಂಗ್ ವಿಷಯ ಹೆಂಗಿದೆ ಅಂದ್ರೆ ನೀವು ಯಾವುದೇ ಉತ್ತರ ಕೊಟ್ರು ತಪ್ಪು ಉತ್ತರ ಇಲ್ವೇ ಇಲ್ಲ, ಎಲ್ಲ ಉತ್ತರಗಳು ಒಳ್ಳೆ ಉತ್ತರ. ಹೀಗಾಗಿ ದಯವಿಟ್ಟು ನಾನು ಪ್ರಶ್ನೆ ಕೇಳಿದ್ರೆ ನೀವು ಉತ್ತರ ಹೇಳಿ, ಆಯ್ತಾ? ಸೊ ನಿಮ್ ಹಿಂದಿನ ಟೆಕ್ ಟಾಕ್ ನಲ್ಲಿ ಕ್ಲೌಡ್ಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡ್ರಿ, ಹೌದಾ? ಕ್ಲೌಡ್ ಟೆಕ್ನಾಲಜೀಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡ್ರಿ. ಮಹದೇವ್ ಸ್ವಾಮಿ ಅವರು ಕ್ಲೌಡ್ ಟೆಕ್ನಾಲಜಿ ಬಂದಿರೋದ್ರಿಂದ ಹೇಗೆ ಕಂಪ್ಯೂಟೇಷನ್ ಎಲ್ಲ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ, ಕಂಪ್ಯೂಟೇಷನ್ ಪವರ್ ಜಾಸ್ತಿ ಆಗಿದೆ ಅನ್ನೋದು ತಿಳಿಸ್ಕೊಟ್ರು. ನಾವು ಇದು ಅದರ ಮುಂದಿನ ಸ್ಟೆಪ್ ಇದೆ, ಹೌದಾ? ಇದಕ್ಕೆ ಯಂತ್ರ ಕಲಿಕೆ ಅಥವಾ ಮಷೀನ್ ಲರ್ನಿಂಗ್ ಅಂತ ಇದಕ್ಕೆ ಹೆಸರು. ಏನಪ್ಪಾ ಇದು ಮಷೀನ್ ಲರ್ನಿಂಗ್? ಮಷೀನ್ ಲರ್ನಿಂಗ್ ಅಂದ್ರೆ ಏನು ಅನ್ನೋದು ಇವಾಗ ಓಕೆ. ಸೊ ಮಷೀನ್ ಲರ್ನಿಂಗ್ ಅನ್ನೋದು ಫಸ್ಟ್ ಈ ಮೊದಲು ದಿಸ್ ಟರ್ಮ್ ವಾಸ್ ಕಾಯಿನ್ ಬೈ ಆರ್ಥರ್ ಲೀ ಸ್ಯಾಮ್ಯುಯಲ್. ಇದು 1959 ನಲ್ಲೇ ಈ ಕಾಯಿನ್ ದಿಸ್ ಟರ್ಮ್ ಮಷೀನ್ ಲರ್ನಿಂಗ್. ಮಷೀನ್ ಲರ್ನಿಂಗ್ ಅಂತಂದ್ರೆ ಯಾವುದು ವೆನ್ ಯು ಚೂಸ್ ಎ ನ್ಯಾರೋ ಟಾಸ್ಕ್, ಆ ಟಾಸ್ಕ್ ನ ಅದನ್ನೇ ಮಾಡ್ತಾ ಇದ್ರೆ ವೆನ್ ಯು ಗೆಟ್ ಬೆಟರ್ ಎಟ್ ಡೂಯಿಂಗ್ ದೆನ್ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ಸ್. So what did he do? He wrote his own program for checkers. Checkers anta one game ide. So popularized the term machine learning, and he wrote a game to play chess tara idon game idu checkers anta. So and this checkers learned the move by itself. ನೀವು ಹೇಗೆ ಒಂದು ಮಗುಗೆ ಚೆಸ್ ಆಟ ಆಡ್ಲಿಕ್ಕೆ ಹೇಳ್ಕೊಡ್ತೀರಾ, 1 ವರ್ಷ ನೀವೇ ಗೆಲ್ತಾ ಇರ್ತೀರಾ, 2 ವರ್ಷ ನೀವೇ ಗೆಲ್ತೀರಾ, but the third year that magu starts beating you, right? So same thing happened. The computer started winning against Arthur Sen. So this was the first time he discovered that they can learn. Computers can learn. So that was the first foray into machine learning. That's how he came to coin the term. So the second definition is a better definition, also came from Tom Mitchell. It says well-poised learning problem. So a well-poised learning problem, a computer program is said to learn from experience E. Okay, let's say there is an experience E, okay, with respect to some task T, okay, and some performance measure P. There is some way to measure what we are learning. Then if its performance on T as measured by P improves with experience E, then there is learning happening. That means there is some learning happening. So ಏನೋ ಕಲಿಕೆ ನಡೀತಾ ಇದೆ ಅಂದ್ರೆ ಏನೋ ಒಂದು ಅನುಭವ ಆಗುತ್ತೆ, ಆ ಅನುಭವದ ಮೇರೆಗೆ ನಮ್ಮ ಕಲಿಕೆ ಕಾಲಾನಂತರ ಇಂಪ್ರೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. It starts improving. Okay, that is called that is another definition for machine learning. ಇದೆಲ್ಲ ಒಂದು ಸ್ವಲ್ಪ ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಆಗಿದೆಯಲ್ಲ, ಏನು ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲಲ್ಲ. ಸೊ ಲೆಟ್ us go to the next. ಸೊ ಇದೇನಿದು ಚಿತ್ರ ಹೇಳ್ತೀರಾ? ಪಾಟ್ ಹೋಲ್ಸ್, ಆಮೇಲೆ ಗುಂಡಿಗಳಿವೆ, ಪಾಟೋಲ್ಸ್ ಇವೆ, ಪಾಟೋಲ್ಸ್ ಅಲ್ಲಿ ನೀರಿವೆ. ಸೊ ಇಟ್ ಈಸ್ ಪಾಟ್ಹೋಲ್ಸ್. ನಮ್ ಬೆಂಗಳೂರಿನಲ್ಲಿ ಇರೋರಿಗೆಲ್ಲರಿಗೂ ಇದು ಗೊತ್ತು ಏನು ಪಾಟ್ಹೋಲ್ಸ್ ಇದೆ. ಪಾಟ್ಹೋಲ್ಸ್ ನೋಡಿದ ಕೂಡಲೇ ನೀವು ಸ್ಕೂಟರ್ ಓಡಿಸ್ತಾ ಇರ್ಬೇಕಾದ್ರೆ ಅದ್ರ ಸುತ್ತ ಹೋಗ್ತೀರಾ, ಹೌದಾ? ಅದ್ರ ಒಳಗಡೆ ಹೋಗೋದಿಲ್ಲ ನೀವು, ಹೌದಾ? ಅದು ಯು ಅವಾಯ್ಡ್ ಇಟ್ and you go around it, but you know that this is potholes, right? So now So there are potholes, there are depressions in asphalt, road surface. So idalli nodid kulle ee chitradalli each potholes is about 3 to 5 feet diameter, right? And there is presence of water. And ಸ್ವಲ್ಪ ನೀವು civil engineering ಅಥವಾ ಏನಾದ್ರು ಓದಿದ್ರೆ you will see that the crack type is crocodile crack types ಅಂತ formations. And this is you will see the type of road. ಇದು ಹೊಸ ರೋಡ್ ನಲ್ಲಿ ಆಗಿದೆಯಾ ಅಥವಾ ಹಳೆ ರೋಡ್ ನಲ್ಲಿ ಆಗಿದೆಯಾ ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ. ಆಮೇಲೆ ಎಲ್ಲಾಗಿದೆ, ಸೊ ಇದು ಅವಳನಹಳ್ಳಿ ಮೇನ್ ರೋಡ್ ಅಲ್ಲಿ ಆಗಿರೋದಿದೆ. ಸೊ ಇಷ್ಟೆಲ್ಲ ವಿಷಯಗಳು ನೀವು ಈ ಚಿತ್ರವನ್ನು ನೋಡಿದ ಕೂಡಲೇ ಅಥವಾ ಇನ್ನು if some of you may know more about potholes, right? So ನೀವು ಇದೇ ರೋಡ್ ನಲ್ಲಿ ನೀವು ಹೋಗ್ತಾ ಇದ್ರೆ ನೀವು ಎಡಗಡೆ ಹೋದ್ರೆ ಬೇಗ ಹೋಗ್ಬೋದು, ಬಲಗಡೆ ಹೋದ್ರೆ ಬೇಗ ಹೋಗ್ಬೋದು ಅನ್ನೋದು ನಿಮ್ಗೆ ಗೊತ್ತಾಗೋದು, ಹೌದಾ? So all this is built in us. This is intelligence, right? The moment you see this, you will know exactly what this is. So ನಮ್ಗೆ ಯಾರು ಹೇಳ್ಕೊಡ್ಬೇಕಾಗಿಲ್ಲ, you know that this is powerful, right? So next we will see what happens next. ಈ pothole ನ ಹೆಂಗ್ ಮುಚ್ಚೋದು? So there is certain methods. So step 1, so cold patch ಹಾಕ್ತೀವಿ, ಆಮೇಲೆ you will clean the pothole first and remove the large and loose rocks and other debris, remove the water and pour and spread cold patch material into the pothole and compact material with the hand tamper, adnella tamper ಮಾಡಿ, then you know how to fix it, right? So again, first you identified what the problem was, now you know how to fix the pothole. And this kind of cognitive ability is already there within us, right? We already have it. Namge ivaga one ನಿಮಿಷ ನೀವು think outside the body and think, okay, we can think about all these things, right? We have this ability. Or das ಹೇಳಿದ್ದಾರೆ ಮಾನವ ಜನ್ಮ ದೊಡ್ಡದು ಅಂತ. So atara, so we have this capability to not only identify the problem, to fix it, right? Now, so ಏನ್ ಮಾಡಿದ್ರು ಮನುಷ್ಯರು? ಸುಮ್ಮನೆ ಕೂತ್ಕೊಳ್ಳಲ್ಲ ಮನುಷ್ಯರು. ಆ ತರ ಫಸ್ಟ್ ಕೈನಲ್ಲಿ ಫಿಕ್ಸ್ ಮಾಡಿ, ಆಯ್ತಾ? ಈ ತರ they fixed it this way and they said there are too many of potholes, ತುಂಬಾ ಇದೆ potholes. So ಏನ್ ಮಾಡೋಣ? ಒಂದು ಮಿಷಿನ್ ತಗೊಂಡು, this is a latest Python 5000 machine which has an automated arm. ಇಲ್ಲಿ ಒಂದು ಕ್ಯಾಬಿನ್ ಬೇರೆ ಇದೆ, ಒಳಗಡೆ ನೀವು ಆರಾಮಾಗಿ ಕೂತ್ಬೋದು. ಕೂತ್ಬಿಟ್ಟು you can supply asphalt, whether it is hot asphalt or cold asphalt, you can supply exactly what to fill the pothole using this robotic arm. But you still need somebody to sit here and do all this, right? Now, what if I don't even want to sit here? I want to come in the ashram and do dhyana while this machine is fixing potholes. Or you do something else, something better, while this is fixing potholes. So can this machine learn how to fix potholes? That is the question, all by itself. So ಈ pothole fix ಮಾಡ್ಲಿಕ್ಕೆ what is this machine has to do? First, it has to recognize a pothole. It has to recognize how big the pothole is, what is inside the pothole, ಯಾವ form ಆಯ್ತು pothole, what kind of a crack it is. All those things it has to know, and it has to know how to fix it. A fix ಮಾಡ್ಲಿಕ್ಕೆ ಏನೇನ್ ಬೇಕು ಅನ್ನೋದು, it also needs to know all that. So what machine learning does is it will try to teach this machine how to fix pothole by itself. That is the attempt to do machine learning. Right? So super clear ಆಗ್ತದೆ ಇವಾಗ machine learning ಏನು ಅಂತ. So ಇಲ್ಲಿ software development ಯಾರು ಮಾಡಿದೀರಾ? Okay, software. We have one person raising the hand. Okay. So if you want to build, of course, Narendra also has done software. So if you want to build software, right, there are some first principles you have to follow. That means you have to, let us say you have to build an e-commerce site, right? You have to first get requirements. Nam software athwa app, mobile app build ಮಾಡ್ತಾ ಇದೀರಾ ಅಂತ. So you need to know what is the requirement. Nam app ಏನೇನ್ ಮಾಡಬೇಕು, ಎಲ್ಲಿ ಹೋದ್ರೆ ಹಿಂಗ್ ಕ್ಲಿಕ್ ಮಾಡಬೇಕು, ಅಲ್ಲಿ ಹೋದ್ರೆ ಹಿಂಗ್ ಮಾಡಬೇಕು. So everything you decide, and this photo you will update, and you like this picture, you go hit buy, and the buy will do payment, and payment will be done, and after that whatever you bought ನಿಮ್ಮ ಮನೆಗೆ ಅದು ಬರುತ್ತೆ. ಇಷ್ಟೆಲ್ಲ ಡಿಸೈನ್ ಮಾಡಬೇಕು. ಇದೆಲ್ಲ ಕೂತ್ಕೊಂಡು very smart people, you design all this, and you say, oh, it is working fine, and we all are happy and we go. But will the same thing work 3 years for 3 years? No, there's situation change. ಬೇರೆ ಎಲ್ಲೋ ಹೋಗ್ಬೇಕು, ಬೇರೆ ಗೂಡ್ಸ್ ಬರುತ್ತೆ, ಅಥವಾ ಡೆಲಿವರಿ ರೂಟ್ ಚೇಂಜ್ ಆಗುತ್ತೆ, the type of goods, the number of people who wants to sell, everything will change, right? So to make that change happen, you have to call the software engineer again, and they have to understand what is the change, and they have to code again, reprogram, ella program ಮಾಡಬೇಕು, ಮತ್ತೆ ಅದನ್ನ deploy ಮಾಡಬೇಕು. So this is, again, you are dependent on somebody to do this. What if that program is smart enough, right, to understand, ನಾವು ಹೊಸದು ಯಾವುದೋ ಪಿನ್ ಕೋಡ್ ಬಂದಿದೆ, ಅಲ್ಲಿಗೆ ನಾವು ಹೇಳ್ತೀವಿ ಸರ್, ನಾವು ಸಾಫ್ಟ್ವೇರ್ ಪ್ರೋಗ್ರಾಮ್ ಅಲ್ಲಿ that pin code delivery is not there. But if the software itself is smart enough to learn, okay, there is a new pin code that is added, I have to deliver to that. So nobody has to change. The software change ಮಾಡ್ಬೋದು. So that ability to change itself through experience is machine. Okay. ಅರ್ಥ ಆಗ್ತಿದೆ ಇವಾಗ ಸ್ವಲ್ಪ? So we will now know what are the core components. So in machine learning ಗೆ ಏನ್ ಬೇಕು ಕಲಿಲಿಕ್ಕೆ ಅನ್ನೋದನ್ನ ನಾವು ಸ್ವಲ್ಪ ನೋಡ್ಕೊಳ್ಳೋಣ. So any machine learning language, so if you go online or if you go anywhere and look up or join any course, there are lots of tools and lots of ways of doing machine learning and deep learning. No matter what it is, these are some of the core components a machine learning algorithm or machine learning system will require. Okay. So one most important thing, you need to have data. You need to have data. So this is one of the most important things. So we need to have data to learn from. Just like how we showed in the pothole example, the machine should know, Chitra nodid kudle, it should be able to recognize that this is a pothole, and it should be able to recognize that data is most important thing. And then we need to have a model to transform the data. So once that data is input into a model, that model should be say, yes, this is a pothole. Just that recognition, ನಮಗೆ ನೋಡಿದ ಕೂಡಲೇ ತಕ್ಷಣ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ ಈ pothole ಅಂತ. ನೀವೆಲ್ಲ ಚೆಕ್ ಅಂತ ಹೇಳ್ಬಿಟ್ರಿ. ಆದ್ರೆ how can machine do that? ಸುಮ್ಮನೆ ದೊಡ್ಡದಾಗಿದೆ, that machine is huge, but ಆ machine ನ ನೀವು pothole ಮುಂದೆ ತಗೊಂಡೋದ್ರೆ ಅದು ಗೊತ್ತಾಗುತ್ತಾ pothole ಅಂತ? ಇಲ್ಲ. So it needs data, and it needs some kind of model where you will feed the data and the output it says, yes, this is a pothole, right? And so now we also need what is called an objective function that tells us how badly or how well that model is performing. So sometimes road nalle jinke bantu, maybe your machine recognizes the jinke as pothole. So then that is wrong, right? So it needs to have this experience saying that, okay, something that is not moving is not a pothole. That is, so that experience it needs to learn. So for that, there is something called objective function, right? So the objective function is always part of a machine learning component. Now, so this objective function will tell how that that model is performing, and to make sure that the parameters that are being used, so parameters are so the diameter of the porthole or the depth of porthole, all those things. So to measure that, to adjust that model's parameters or to optimize that objective function, you will need an algorithm to adjust that. Okay. So all these, you need these four, always they are part of your machine learning methods. So what we'll do next is we'll go in a little bit detail into understanding each of these core concepts. Okay. So far with me? Okay. Thank you. Yes, sir. All right, let's see. So this, as I said before, the ML core component is data. With data, we can't learn anything. Even for San Moguge, you will keep telling the child, okay, orange hingirate, tomato hingirate. So that is all data, right? You are giving that child data and the child is learning from you, right? So similarly, we have this collection of examples, right? So say, for example, if I have a database of apartment sales in Bangalore, right? So each apartment has some features, right? An apartment has certain square footage, has some, number of bedrooms, number of bathrooms, so on and so forth. So those are all, those are called attributes and features for each of them, right? From which the model will make predictions. So let us say that I have an apartment, it is X square footage, it has so many bedrooms, so many bathrooms, and it costs, so many. I have learned a new term in Bangalore, it's called CR. So I didn't know what CR was. So you go to any apartment, they'll say 1.2 CR, 2.5 CR. I didn't know what was CR means. So that is the price we want to know. What is the price of your apartment, right? So that is called a target or a label, right? Given this set of examples, and each example has set of attributes called features, okay, from which we'll make predictions. And based on that, we will arrive at a target or a label, right? And this data is expressed in numerically. So this is where your mathematics will come into picture, right? So all this information is represented as numbers, so as vectors. And this is called dimensionality of data, right? So you will know more about this as you learn more about machine learning, but we'll just keep it at that for now, right? And then always more data is good. The more data that you have, less assumptions we can make. So in case of pothole, the more data you have about the pothole, asphalt road melirutte, ಅದು ಇಷ್ಟು ಆಳ ಇರುತ್ತೆ, ಇಷ್ಟ ಉದ್ದ ಇರುತ್ತೆ, ಇಷ್ಟು ಅಗಲ ಇರುತ್ತೆ, ಇಷ್ಟು ಸಲಿ ಕ್ರ್ಯಾಕ್ ಆಗುತ್ತೆ, ಮಳೆಗಾಲ ಬಂದ್ರೆ ಇರುತ್ತೆ. So the more data you have about the pothole, the less assumptions your model has to make. So more data is good, right? But at the same time, the data has to be right. That is also most important. If the data is wrong, then what you are predicting, the target or label will also be incorrect. So the same, that you have already heard, garbage in, garbage out. also holds good to it. So we have to make sure that data is right. Another thing that you have to keep in mind is the data has to be take into consideration some bias. So you are, say for example, you have you are building a skin cancer recognition system, right? So you build a huge database, you're using a huge database of people, and then you build a skin cancer recognition system, but you didn't take any brown skin people into consideration. So then if you go and scan, it will say, yeah, I don't know, or it will say, you don't have any cancer, because it does not have brown skin data, right? So you have to make sure that the data that you have is big, large number of data. The data you have is the right data, and it also has a good coverage, right? Then only the machine learning can predict correctly for you. Does that make sense? Okay. So we talked about data. Now we talk about the model. So model means it is a computational machine. So you just think that it is like a box. So you prepare the data, you have the big data, you have all the right data, you have unbiased data, you have all the features, everything good. Now you put it through the model. And model is the one that predicts the output. Okay. So let us say that you give a list of a set of apartment information, and model will tell you what the price of that apartment, or what is the price range of that. Or you give the model a set of data, and the model will tell you whether this is a pothole or it's a deer, right? Jinkena athwa pothole anta helte. So Karadina. So I don't know. So it should be able to understand. So outputs, predictions, possibly different types, and data can be chained together to top to bottom, transformation of data resulting in deep learning. So you can also, within the model, you can have transformations happen. So that happens during deep learning, where it's not just the data itself, but you can have transformations of data happening, and they are all chained together. Say, for example, you are looking at an image, and image nully you will see just kiwi. You will just kiwi. Just ear is like this, and the next image you will see a tail which is like that. And based on that, you are able to conclude that, oh, and then maybe in the next transformation data that there is a bark associated with it. So this model is able to connect these three and say, oh, it is a dog from that picture, right? So that is part of what is called deep learning. We will maybe in next session, if there is one, we can jump on. So we'll get to the next. Okay, we'll go to the next one. Okay, so these are called objective functions. So this is very important. This is like somebody who is saying, okay, are we in the right track? So every time we move, somebody has to tell us, are we going in the right direction? So it's like your pilot or navigator, right? Are we going in the right direction? And that's what the objective function does. So objective function essentially is measure how good or bad the model is. And it has something called loss function. That means, so there is a picture of the pothole, that is the ground truth, but your model is predicting it's a crack, right? Your model is saying it is a crack. So there is some loss between what your model is saying and what the ground truth is. So that is called that is measured by this loss function. So we'll keep working and improving that so that next time it has more experience, so that it will say that it is indeed a powerful, right? So we will keep moving in that direction. But that is what we want to keep this loss as less as possible. That is the key, right? The last function, the loss, the more or less it gets, that means your model is doing better and better. Okay. So for how do we do this? So for this, what we will do is we will get a set of data. Let us say we have, I go back to the apartment data. You have all the information about the apartment data, and we divide that data into, let us say, 80% and 20%. 80% we train the model using that 80% of the data, right? And then after we train the model, we build the model, and we then, in the 20% data, we test it. Is it predicting correctly? Is the price range, whatever the price range that has to be in white field, is it showing correctly, right? So it is like almost when you prepare for your midterm exam, or there's a mock exam, right? Before the final exam, preparatory exam. Preparatory exam, you do excellent. Does it mean that you will do excellent in final exam? So similarly, but preparatory exam will give you a good indication of how you might do in the final exam, right? So training data set and test data set, you can think of them as preparatory exam and final exam. So preparatory exam, we train, we do our best to have the model understand, and then we run it against the test data set. There's a good chance that it will do well, but does not necessarily mean that it will perform the same. When it does not perform the same, it is called overfitting. Okay, so we will then do corrections and make sure that it conforms to our training data set. Okay. That's how the machine learning keeps happening. So it is still not very clear, but I think you are getting a good idea as to how these four components are coming together. Okay. Okay, so this is the final core component of optimization, of the machine learning components. So this is an optimization algorithm, and what you see here this is a simple graph that I'm showing here. It's a gradient descent, which is very popularly used. So this is how machine learning kind of corrects itself. So this is where we start. This is where the machine learning starts when the training happens, right? Either objective ಏನಪ್ಪಾ ಅಂದ್ರೆ ಇಲ್ಲಿಗೆ ಬರಬೇಕು ಹೌದಾ? So every time it corrects every node, it will say, hey, how far I am from the reality, right? From the lowest part of this graph, right? So, and it follows that path. But sometimes what happens is, there may be a lowest part somewhere here, and it may go here also, right? So we need to be careful. But we use this algorithm to make sure that your model keeps learning and gets better, and this towards the ground truth. Okay. So that is about the core components. Any questions so far? Okay. So machine learning, you got a good idea of what are the core components, right? What you need for machine learning and why machine learning is different, right? So we'll now look at some practices. That means, okay, now idella tilkondvi ivaga, what are the different types of problems we can solve using machine learning, right? How can we solve those problems? So there are two main things. One is called supervised learning and unsupervised learning. So we will quickly touch on some of these, how it works with both supervised and unsupervised. Narendra, how am I doing with time? Huh? I'm doing okay? Okay. So supervised learning is, we talked about training inputs and training labels, right? So let us say that we are looking at some corona patients, like we have a list of corona patient information. So corona patients have we have some certain symptoms, right? So we will also give labels to that data, right? While we are inputting that data, we'll also give labels to that data, and that labels ಅಂತಂದ್ರೆ ಇವ್ರಿಗೆ ಇಷ್ಟು ಫೀವರ್ ಇದೆ, ಇವ್ರಿಗೆ ಇಷ್ಟು ಟೆಂಪರೇಚರ್ ಇದೆ, ಇವ್ರಿಗೆ ಇಷ್ಟು ಕಾಫ್ ಇದೆ ಅಂತ we have the data and we have that example, and we will also add a label to it, right? And that label will say this person has corona or this person does not have corona, yes or no. That information we will add, right? And this we will and this training, this is called training the data sets, right? So this can be, or by automatically you can obtain this information because some hospital data is already there, or you can have somebody manually put the labels for that data, right? Then we are saying this given this set of examples, this is what the label should be, okay? Then with this, what we will do is we'll run it through the model, right? And the model is built. Now what you will do is you will give a set of new data, right? This 45-year-old person came, and this person has so much temperature, ಇಷ್ಟು ದಿವಸದಿಂದ ಇವ್ರಿಗೆ ಜ್ವರ ಇದೆ, ಆಮೇಲೆ ಇವ್ರಿಗೆ ಎಷ್ಟು ಫೀವರ್ ಇದೆ, ಕಾಫ್ ಇದೆ ಅಂತೆಲ್ಲ you provide this information, you put that information into this model and you will get an output, right? So our label could be corona or no corona, and input labels fever, cough, smell, loss of smell, taste. So that information, right? So you use a huge amount of data, you label them, that is through this supervised learning, and then you build this model, and for the fresh data that came in, you are now able to predict whether this person has corona or not. And that is a basic concept of how supervised learning works. Okay. Did that make sense? Yes. So same concepts you can use for whether, so this you can use to predict whether somebody has cancer or no cancer, or you can also do translations, right? You can somebody wants to translate something in French. ಇವಾಗ ಕನ್ನಡದಲ್ಲಿ ಫ್ರೆಂಚ್ ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡಬಹುದು. So they will put this training labels, right? And then that kind of problem can be solved through this, okay? And this is most popular is prediction of stock values, stock prices, right? So you take this, Narendra is smiling. So you take this stock data, stock prices, and you train the model, okay? So you ಗೊತ್ತಾಗುತ್ತೆ ದೀಪಾವಳಿ ಟೈಮಲ್ಲಿ ಇದು ಮೇಲೆ ಹೋಗುತ್ತೆ, our Christmas time ಕೆಳಗೆ ಬರುತ್ತೆ, ಆ ಥರ you will see, and then you can put the training labels, build the model, and now say I want to buy this particular stock, it will tell you what the stock price is going to be. Okay. So this is how I'm kind of simplifying it, but in general, that's how the supervised learning works. Okay, did that make sense?
Yes.
So in the learning process is very simple. We will just grab some data and select from the random subset, right? And acquiring the ground truth labels for each of them, and that we will use finally to produce this object. We will go a little bit deeper into some popular supervised learning algorithms, right? Very, very popular. I'll just introduce them to you, and please feel free to go and read up on them. This is very, very interesting, right? Very interesting. So we will learn something about regression and classification. These are very, very popular supervised learning algorithms. So regressions, regression is something that we use for predicting prices. So a range of price. So let us say that this x-axis is square footage, and y-axis is the price, right? And y is a function of x, right? Y equals to f of x. So, and then you will, based on the square footage, you will see prices everywhere, right? And if I give you a new square footage here, then you can just connect it to this and connect it here, and you can come up with what is the price of that. So this is a classic problem. So this problem is called regression, where you will get a price given where you are given a variable. You have a variable x, and then using a function, you are now able to predict what y value will be. So apartment price eshtirutte anno range nimage idrinda sigutte. So this is a classic problem, and it is called regression. So I just put these Sajapur, Whitefield, Indranagar. So this is all the prices. This is 2-bedroom, 2-bathroom. I don't know what the third one is. But then, so this is 60 meters from the nearest mall. So instead of the ashram. But anyway, so all this goes into what is the price of the house, apartment, right? So another very, very important algorithm, that is, this one is called classification. So you have two types of things, right? Let's see. So you see a snake, right? And you want to lift it. But before you lift, you want to know whether this is poisonous or not, right? So you will build a model, machine learning model, where there are two types of snakes, class A and class B. And class A is poisonous and class B is non-poisonous. Non-poisonous, no problem. You can take them, put it everywhere, no problem. Poisonous, not good. So now you got this picture of this snake. Now we need to know what is this. Is this a poisonous or a not poisonous, right? So, oh, sorry, just go back. So we use this classification to figure out whether this is a poisonous snake or not, right? And even when we use so now let us say that we put this picture through our model. Let's say we took pictures of all snakes, and we took him and we took him. He's an expert in poisonous snake. He's expert in non-poisonous snake. And you brew Ratri Ella picture. They saw the picture. They said poisonous, non-poisonous, poisonous, non-poisonous. They built that model, right? And now this model is built, and we have this. The model is there. Now we took this picture and we put it through the model. And what did the model tell us? Model. Let us say the model told us that, hey, 70% this is not poisonous. Okay. So do you want to try this or not? So for that we have an algorithm. So we put them through a we have a loss incurred by handling the snake. We have some kind of an outcome. What is the probability? So we run that outcome through this algorithm, and the algorithm says, okay, the loss incurred by handling the snake can be 0.3 times infinity plus 0.7, which is 70%, times 0, whereas the loss of this becoming of discarding this, not touching this, is 0.3 times 0 plus 0.7 times 1. So our first equation said the the point of touching this snake is infinity, whereas point of not touching this snake is 0.7. So that came out as a positive number. So obviously we don't want to touch this snake, even if your model is saying 70% this is non-poisonous. And if you talk to any snake expert, this is a black mamba, extremely venomous snake. So this is how the machine learning can work with you. And even if there is a prediction, you can still use mathematics to understand, what actually the outcome would be. Did that make sense? So that is a picture of black mamba. It is definitely possible. So now there are other supervised methods. So we looked at both regression and classification. Classification, we can tell whether this is a poisonous snake, non-poisonous snake, and you can use the same kind of logic whether this is a cat, this is a dog. So we can easily identify those. Yes or no question. Your cancer idea, corona idea, those things you can kind of. But what if you have a picture like this? How can the machine know idu kolina, idu bekka, idu kattena? How can it know? Because there are all of them. So we had learned about only, very simple kind of tagging, either cat or dog. Now we have to deal with this kind of pictures where we have to work with multi-label classification. Okay. So we will tag everything. We'll say this is a rooster, this is a cat, this is a dog, this is a donkey. We'll tag all of them, and we will let our model know about these. Okay. So that is also available. We also have. So I'm just talking to you about what are the applications of machine learning. So we have multi-label classification, and then now it can also, once you have multi-label classification, you run this picture through that particular model. It will not give you just one answer. It will give you all these. Whatever, if all these four are present, it will tell you. If you give a picture with just dog and donkey, it will tell you, hey, this is dog and donkey. So it will give you two answers, right? So that is also possible. And search, that you go to Google and you do the search, and the Google has to surface to you the closest to what you typed in, right? It's a very difficult problem. So So they use some kind of a page rank mechanism where they rank the pages and to make sure that the highest rank page is available to you. So that is also part of machine learning. And you have okay. So now, you have recommender systems. So if you go to watch a movie on Netflix, or if you go to watch something, or if you want to buy something, okay. So if you want to go buy a flashlight, then the recommender system will say, hey, buy battery along with it. That recommender system is telling, because it knows that along with the flashlight, you need batteries. When you are buying batteries, they say, hey, buy the bag. So this is all due to recommender system telling you, how they are all connected with each other. It's again, that there is no person sitting there saying, oh, this person is buying flashlight, we should also tell him to buy batteries. You anಗಡಿಗೆ ಹೋದಾಗ ಹಂಗೆ ಹೇಳ್ತಾರೆ. So ಇದನ್ನ ತಗೊಂತಾ ಇದ್ರೆ ಅದು ತಗೊಳ್ಳಿ ಮೇಡಮ್, ಇದು ತಗೊಳ್ಳಿ. So similarly, there is a recommendation system that's happening automatically. And there is sequence learning. So sequence learning is it's a very, very interesting topic where you have video streams coming, and each video streams are different size. See this, so some of the images we can kind of control, but if video streams are coming continuously, you can't control, right? So sequence learning is something where you can actually you need to react very quickly and train very quickly with different frames of videos, and to be able to understand that. And sequence learning is also machine translation. So somebody wants to translate, they want to translate something to some other language, one word. Somebody wants to translate one, sentence. Somebody wants to translate a paragraph. So we should be able to respond to each of them. And then this is called automated speech recognition and text-to-speech conversion. And that we'll see a demo of that later. So that is also part of sequence learning. So this is a very interesting and very difficult problem, but very effective problem that is going on in machine learning. So here the interesting part about this is both input and outputs are variables, or they are variables. So that is what makes it really challenging. Whereas you saw in the classic regression problem, you already had the price data, and you have to do f of x, and you will get y. So y is, we know that it's a finite length. So just give a very quick, very brief introduction to supervised learning. I will also talk about unsupervised learning. So unsupervised or self-learning, and this is where we want our pothole machine to be, right? We want our pothole machine, if a pothole machine is running on the streets of Bangalore for 3 years, it should know everything. Yell turn madbeku, henge, yelli jasti potholes irutte. It should get all that information. It should learn by itself. So that comes through the environment. So can we have, so essentially in unsupervised learning, there is a small set of prototypes that accurately summarize the data. You give them a set of photos, and I give you a bunch of photos. Then you can say, okay, this is landscape, this is wild animals, this is portraits. So you're able to classify and learn from them. And then now next set of data that I give, you can say, okay, this belongs to this particular cluster of information. So that here again, similarly, what we saw in supervised learning, you have training inputs and training labels. But these labels are coming through the environment, right? And there is no, it's almost like supervised learning is like you are having a boss, and boss is telling, hey, do this, do this, do this. In unsupervised learning, boss is saying, I don't know what to do. Here is the data, and you are the data scientist, you do something. So now it's your job to figure out what to do, right? So that is what happens with unsupervised and self-learning. Right? So we take bits and pieces of information, and people are able to figure out and connect the dots, and then come to conclusions based on that. All right. Okay, we're almost here. Any questions so far? So what did we learn so far? I'll just quickly summarize. So we learned machine learning is the ability for the program to learn by itself, right? And not only just learn, it is getting better and better by itself, right? And we also learned about the ML core components. We learned about data. We learned about the models. We learned about objective function, right? Objective function is used to measure whether, hey, is the model doing better? So model is when you put the data into the model will give you the output, which is the targeted label, and then optimization algorithms to make the model even better, right? So that we learned. We also learned about supervised and unsupervised learning, and the next you want to learn is deep learning. There is some, the next step is something called deep learning, where we use transformers. They are using deep neural networks or neural networks, where each levels of nodes do certain transformation on data and pass on that information to the next level, and it keeps getting better and better, right? So that is a very exciting field of machine learning. There is a lot of research still going on there, but there is also a lot of tools already available. All you need is a bunch of data, and then people are giving machine learning platforms where you can load your data and get these things done. And what is very exciting to me about machine learning is it's almost like the days of electricity or days of internet, when the internet just started. So machine learning is we are also at a very exciting times, right? And the best part of machine learning is it is not restricted to just technology people, right? Doctors need machine learning. Lawyers, you can put legal documents using machine learning. Language people need machine learning. There are people who are writing novels using machine learning. So they put all this bunch of data, and before you know, it will do volume 1, volume 2, volume 3. So there are people who can do. So people in arts, people in science, people who wants to build roads. So machine learning is going to touch agriculture. Agriculture is amazing. So you can predict your weather. ನೀವು ಯಾವ ಬೀಜ ಯಾವಾಗ ಹಾಕಬೇಕು, ಮಳೆ ಯಾವಾಗ ಬರುತ್ತೆ, ಆಮೇಲೆ ಇದನ್ನ ನಿಮ್ಮ ಹೊಲದ ಫೀಚರ್ಸ್ ಡೇಟಾ ಅದೆಲ್ಲ ಹಾಕಿ ನಿಮ್ಮ ಸಾಯಿಲ್ ಎಂತದ್ದು, ಎಷ್ಟು ಗೊಬ್ಬರದ ಸತ್ವ ಎಷ್ಟಿದೆ, ಎಲ್ಲ ವಿಷಯಗಳನ್ನ ನೀವು ಹಾಕಿ ಒಂದು ಮಾಡೆಲ್ ಮಾಡಿದ್ರೆ it can tell you ಈ ಸೀಸನ್ ನಲ್ಲಿ ನೀವು ಯಾವ ಬೆಳೆ ಬೆಳೆದ್ರೆ ಉತ್ತಮ ಅನ್ನೋದನ್ನ ಹೇಳ್ಬೋದು. So even farmers will need machine learning. So obviously transportation. So even Swamiji might need machine learning. I'm sure he will need machine learning. So he can manage his time better. He can manage the school time better, and he can predict. Yes, ಯಾವಾಗ ನಾವು prayer time ಇಷ್ಟೇ ಜಾಸ್ತಿ ಜನ ಯಾವಾಗ ಬರ್ತಾರೆ ಅನ್ನೋದನ್ನು machine learning use ಮಾಡಿ. So it's I think that is the exciting part of machine learning. So it kinds of spans across the fields. It's not just restricted to technology field, and that's what makes me happy to be involved in this particular field. And we'll just do a quick demo and then we can close. So we'll do a demo of one of the things about unsupervised learning. We were talking about automated speech recognition and text-to-speech conversion. Alexa, what is the weather in Bengaluru?
It's 22 degrees Celsius with mostly cloudy skies. You can expect more of the same tonight, with a low of 18 degrees.
Okay, so it told that today's weather, and it also gives you the weather 12 a.m. ಏನಿರುತ್ತೆ 3 a.m. ಏನಿರುತ್ತೆ. So it also gives you the range of that weather, and it also gives you the weather in Bengaluru, and what does it feel, the real feel as to precipitation, as to wind, how direction blow. So you just ask for weather, but it gave you all this information. Now you ask for weather in Bengaluru. So it understood that this person is asking for weather and in a specific city, right? You can also, so you can name any city you want in the world. It will be able to give you that information. So all this, so it has to recognize my voice, that is called speech recognition, and it has to convert that speech recognition, whatever it recognized, into some text. And then it has to understand that text. Oh, ಇವರು weather ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ಇವರು ಬೆಂಗಳೂರು weather ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ನಿಮ್ಗೆ ಅದು ಏನಪ್ಪಾ ಇದು ಇಷ್ಟು ಸುಲಭದ ಪ್ರಶ್ನೆಗೆ ಇಷ್ಟು ಕಷ್ಟ. ಬಟ್ ಮಷೀನ್ ಅದನ್ನ ಅರ್ಥ ಮಾಡಬೇಕು. It's not simple, right? And then it has to go get that information maybe from weather.com, and it has to bring that information back to this device and play it from text to speech. So it did all that, right? So ಇನ್ನೊಂದು ಪ್ರಶ್ನೆ ಕೇಳ್ತೀನಿ. Alexa, who is the Prime Minister of India?
The current Prime Minister of India is Narendra Modi.
Alexa, how old is he?
Narendra Modi is 71 years old.
Okay. So I asked a very simple question. Prime Minister of India yaru? Amele ನನ್ನ second follow-up question, I didn't tell her whose age I'm asking. I asked what is his age. So it is able to understand through the environment that I'm still talking about this person, who, the Prime Minister of India, and it is able to tell his age. Now, ಇದು ನಮಗೆ ತುಂಬಾ ಸಿಂಪಲ್ ಕೆಲಸ ಅಂತ ಅನಿಸ್ಬೋದು, but for machine to say, okay, this person is referencing Narendra Modi, and first I asked who is the Prime Minister of India, ಹೇಳ್ತು. Second, Narendra Modi's age. So that information it is able to understand, right? It's able to reference to back what it means. Alexa, tell me about Swami Vivekananda.
According to Wikipedia, Swami Vivekananda, born Narendranath Datta, was an Indian Hindu monk and philosopher. He was a chief disciple of the 19th century Indian mystic Ramakrishna. Influenced by Western esotericism, he was a key figure in the introduction of the Indian darshanas of Vedanta and Yoga to the Western world, and is credited with raising interfaith awareness, bringing Hinduism to the status of a major world religion during the late 19th century.
So it is able to get this information and give this to you. And most important thing is, ನಾನು ಇಲ್ಲಿ ಹಿಡ್ಕೊಂಡಿದ್ದೆ ಬಟ್ ಇದು ಹಿಡ್ಕೊಳ್ಳೋದು ಏನು ಅವಶ್ಯಕತೆ ಇರಲಿಲ್ಲ. ನನ್ನ ಫೋನ್ ಇನ್ನ ಪಾಕೆಟ್ನಲ್ಲೇ ಇದೆ, ನಾನು ಫೋನ್ ತೆಗಿಲಿಲ್ಲ, ಫೋನ್ ಸ್ವೈಪ್ ಮಾಡಲಿಲ್ಲ. It is able to understand my voice. Just imagine ಇವಾಗ lot of people who are older and we have to see where I'm swiping ಅಥವಾ ನಮ್ಮ ಹಳ್ಳಿನಲ್ಲಿ. ಸೊ ಅವ್ರಿಗೆ ಮೊಬೈಲ್ ಫೋನ್ ತೆಗಿಬೇಕು, ಆ್ಯಪ್ ಮಾಡಬೇಕು, ಮತ್ತೆ ಅದನ್ನ ಒತ್ತಬೇಕು, ಸ್ವೈಪ್ ಮಾಡಬೇಕು, ಏನು ಅದ್ರದ್ದು ಅವಶ್ಯಕತೆ ಇರೋದಿಲ್ಲ. You can just speak to it and it will reply. So that is one convenience that you get. Okay. So thank you for giving me the opportunity to share whatever I know about machine learning, and I wish you all the best, and I hope you will continue to progress in this very exciting and new field of machine learning. Thank you very much. Oh, any question?
Sir, it's close. So my first question is this is all about how AI model, how to learn about artificial intelligence, but how to just use it as a model.
Yeah. So you learned about the core components of machine learning. So artificial intelligence, you can kind of it is now machine learning. Even though machine learning started out as a part of artificial intelligence, now they are more synonymous, both machine learning and artificial intelligence. So what you need is you are asking how to get started, right?
No, sir, not into the learning part, just to use it as a tool.
Yeah. So there are a lot of tools available on the web. Say, for example, there is ImageNet, where there are already thousands and thousands or maybe millions of images of animals, plants, everything already available. So you should be able to go use that. There are also other tools like PyTorch, Amazon SageMaker, Microsoft has tools, and Google has tools. So you can use those tools, and you don't even have to write any code. You just need to supply your data, and you can use the output of already built model. So models are already there. You just need to supply the data. So all the training and labeling is all done. You just need to supply the input data into the model. Model is also already built, and then you can get out. So you should be able to use any of these tools to get this. I didn't mention those tools because I didn't want to, say that these are the tools that I'm proposing, but there are lots of tools like that.
Sir, and the next question is how to start micro projects. We were all thinking, who are all in Mandiram as engineering students, we wanted to do some hands-on projects on machine learning and all those things. But the problem is we don't know how to select a simple topic and do on all those things, like a micro project. We tend to choose a big one and we end up not doing it.
Right. So choose a small thing, that something that you are doing, repeating again and again, where you think that, hey, my time is better spent doing something else, but I'm doing this again and again, or you see your teammates doing the same work again and again. So that is something that you can automate. That is looking for automation. And even in, helping out your neighborhood, maybe you just go in the neighborhood, maybe you take pictures of potholes, I'm just saying that is something quickly you can put together, and you can share that information with the local government and say, hey, we have identified all these potholes. You can take that as your first project where, you can ask somebody to post pictures and put it into your model, and your model will say, yes, this is a pothole, this is not a pothole. And you can, whichever said that this is a pothole, you can send it to the local municipality and say, here is the pothole, here is the location that needs to. So those are small projects that I can think of, but you need to sit down and brainstorm. So you now have this information, right? You know what is machine learning, what it can do, what are the core components, what are the different types of problems it can solve, especially pick a regression or a classification, right? That is the simplest place to start. The regression means, okay, given X, find some function of X to get Y. So whether it is, apartment prices or anything like that, any range, or pick a classification. You can classify into two, class A and class B, and then given a input, you should be able to say whether this belongs to class A or class B. And that can be anything. So once you build these two models, you can then take it to your, suppose you village in the village go be. What are the data? What is the data that I can get from my village? Whether it is weather related, warming related, and then get that data and see whether you can solve it through a regression problem or a classification. Did that make sense?
Yes, sir. One more question. Like listening to all these things, sir, we at the first stage we feel like all these things are impossible for us to do. It's very hard for us to learn all those things. But as you have experienced and have experienced learning all these things, would you say like it is also simple like physics, chemistry, and all those learnings? So you can also do just start, or is it like, yeah, it is tough. You have to give a lot of time. You have to stress out yourself.
So the tools are already there. You can start off using existing tools, and you can start working on them. But there will come a time when you think the tools may not be sufficient, right? You want to say, hey, you know what? I'm already using an existing model, and this is not predicting the poisonous snakes properly. I want to do this a little bit better. Then you will have to build your own model. You will have to get your own data. You will have to do your own labeling, right? So that will take some effort, but start off with existing tools, existing images, existing data, existing labels, and see how it works, how it starts, and how you then start identifying the problems that you can use with the existing tools. And later, as you learn more, and you will see many of them are extremely good, are very good, but you may find them not sufficient for you. That's when you need to know a little bit of mathematics, right? So focus on linear algebra. Focus on vectors, right? So little bit of mathematics you will need, some knowledge, calculus if you still want to learn, and that will kind of help you to do more research in this place, in this space, right? And then you can have your own algorithms and beat the existing models that are already. But the existing models are very good. I mean, there are scientists who are already working and they have accuracy, very high accuracy. So you should be able to do good by using existing models. However, there are some problems. Like, say, for example, skin cancer recognition system. There's a wonderful skin cancer recognition system, somebody might have built it somewhere, but they may not have taken, our attributes into consideration. So you may want to improve on those. Did that make sense?
Yes, sir. Thank you.
Namaste, sir.
Namaste.
Sir, what kind of evolution can we expect in the field of education for future generations? Because already the virtual education has disturbed the students. And furthermore, there won't be teacher-student communication or interaction in the coming days. So, what is the evolution that can be expected, sir, through ML?
So it's a great question, and we also look at it as an opportunity, right? We also look at it as an opportunity to improve, to know better. Maybe the remote education is prompting teachers to provide more attention to individuals, right, than when they would be in the class. So they are actually paying more attention towards what they are doing. Doing online education, submitting online homeworks are more efficient because you can kind of do it at your own pace, at your home. But machine learning will help education. Say, for example, in translation, in just like how I mentioned in speech recognition, text to speech, and sequencing, where you have sequence of things coming in. Maybe people don't have proper internet, right? So maybe there is a sequence of requests or questions. It won't get. You want to make sure that they won't get dropped. They will be cached somewhere. And once the network gets opened up, you can keep sending those sequences so that teacher will get that information eventually. So we can do, all these kinds of things. Did it help answer your question?
Yes, sir, but that virtual education has already disturbed, sir.
Yeah, so virtual education, like a face-to-face education, you can't beat, face-to-face education. But virtual education is, we are here, right? So we have to make the best out of what we can. So let us use the tools that are available. You have, you can provide questions online. You can use whiteboards online. You can raise your hands. So people, I think online education is giving opportunity for students to interact more easily with their teachers, because now teacher has to come back and say, oh, I have 5 people who have raised their hands. So they can go back and say, okay, let me go one by one. Whereas maybe in the classroom you would not raise the hand, right? So that there are some advantages, and we need to make use of these, right? Yes. And make the best of the situation.
Yes, sir.
Obviously, our health and our safety is not.
Okay, sir. One more question, sir. How is for army and all, can we use it as a privacy thing? ML machine learning can be used as a privacy matter for not leaking the information of the army.
Yeah, that's a great question. So, so obviously, to have a good model, a great model, you need to have large amount of data. You need to, when I say large, I mean it's huge amount of data, and then you have to have correct data, and you need to have the right data. And when you have all this data, sometimes this data is, can be very important to your country, right? To the country. So we need to have equal security measures while we are dealing with the data. We can't just expose them anywhere, so people can have access to this data easily. So that's when you may want to build your own machine learning model, because then you not only have control of your model, but you also have control of your data and the labels. That may require you to build your own machine learning model instead of depending on either commercially available models or models that are already available instead. So you are absolutely right. You need to take the security of the data, the privacy of data. Maybe there is a health-related information that you want to keep it private for individuals, right? You can't expose that information in public because health data is private, and maybe you have payment-related information data that you don't want to make it public. So you'll have to look at the data privacy and security, and then figure out, can I use a public model for this data? It's a great question.
Thank you, sir.
Sir, namaste, sir.
Namaste.
So, what is the difference between embedded programming and artificial algorithm, machine learning algorithm?
Okay. So embedded programming means if this is a device, right? Now this device has some chip, some microchips, right? And I can make this device do something if I program something into that device, and the device can do it all by itself, right? But the device is self-sufficient with these embedded chips, right? So in case of most of the machine learning solutions, you will need access to huge data, right? So there's a good chance that you will go to the cloud and run through the model and then come back to this device, right? So two things: embedded is self-sufficient. You don't need to be connected. That embedded is able to solve problems on its own. And then embedded programming is you are programming to that specific chip or device that is there. Whereas in case of our machine learning, you will need to use large amount of data that may not be possible in your watch or pen. You may need to go to the cloud to do it. However, there are maybe there already are where there's machine learning embedded within the devices as well. So that people are working on that. That is also possible. So that it's moving there.
So, can we call that embedded devices as artificial intelligence?
So, an artificial intelligence, Turing gave a definition of artificial intelligence. That was a long time ago. Turing theory, you must have all heard of, is one of the pioneers of computation. Turing said that if you are having a conversation with a device, and if you are having a conversation with a person, and you are not able to figure out whether you are having a conversation with a device or a person, then that is artificial intelligence, right? So I remember when I was doing my 30 years ago, when I took my NLP course, I was required to, as a part of the elective course, I was required to write this software called ELIZA, which was here to have a conversation. So ELIZA would say, "Hey, Phanindra, how are you doing today?" So you would say, ELIZA would say, "I'm doing fine. How are you?" You couldn't have an actual conversation, but the conversation was all based on certain rules, right? So, so that is artificial intelligence. Now, in case of the pothole machine, you train that machine, you put the data, it knows what the potholes are, and it's able to drive by itself and fill the potholes by itself, identify the potholes, fill them, and then come back. That would be artificial.
So we can call it as extension of embedded system.
Yeah, I mean, embedded system is you have a pen, or it's a chip. And so you have multiple chips, and you write program to make the chip work, or a drone or something like that. So that is very localized, right? Specific. Yeah, it's very localized. It will do a specific task, right? And it will do the task to what that embedded chip can do, right? So let us say there is an embedded chip in a drone, and you fly the drone over your farm, and that chip has a sensor, and it can sense that there's a certain temperature of that farm. So if certain temperature is there, then you have to put water. So it's a very specific task that it can. So you are right, in a way, embedded systems can be part of an artificial intelligence solution.
Okay, sir. Thank you.
Thank you.
What students are good, but it was very nice, especially for the students. Phanindra, it was very nice, especially for the students and also persons like me who are non-software and also non-computer engineers. My question is, you are mentioning about automatic speech recognition and also text to speech. Both are in a fairly advanced stage, as we see from the demo and other. Similarly, is speech to text, which is also, I think it's called also ML. Is that any progress which has been done in equally to the level of text to speech for the speech to text?
Yeah, that's a great question. So, so one of the requirements for automated speech recognition is you can just use the voice waves to understand what somebody is saying. That is one. You can also recognize that speech and then break that down into text. Right? So that is another way of. So you can have a voice, continue to have a voice component as a part of the output of the recognition, or you can have that output of recognition as text. And when you produce the text, that means you are taking the speech as an input, your voice, and then you're looking at the modulations, you are breaking that into text. So that is already happening. So that's what most of these Google Home and Siri and Alexa, they all do that. So they are able to convert that into text. Now, there are also tools that are available. If you go to the web, you will see there are a lot of tools that are available which can convert speech into text. Now, are they there for all languages? It's a good question. Even if they are there for all languages, how are they performing? That is also a good question. That is something that we can examine. But there are such tools already exist. Yeah.
But which is the best?
So all are equally good. So they are all based on very fundamental algorithms, right? So if you look at speech recognition papers, So most of these researches are done in schools like this, right? And that's how they get into the research work. And so most of them have very good fundamental research done, and they are all based on mathematics. So they are all equally pretty good. But still, there is a lot of work to be done, especially when the way how we speak, right? Say, for example, in India, we say, what is your phone number? So my phone number is 3335577. So now the recognition system needs to understand what is 333, what is 77. So there are things like that. When people will say numbers, and people talk fast, and there are children who will keep saying something. So you still need to, as parents, we perfectly understand, everybody understands, and machines understand what children are saying. Not yet. So we are not there yet in terms of, those are the problems I think people are working. Thank you.
Namaste, sir.
Namaste.
I just need a suggestion, sir, related to academics. So in undergraduate courses, we have AI, AL, and ML, and CS. Both we have, sir, separate. But my process is going on in admission in engineering. So I have got a lot of suggestion. First, you take CS, and in masters you can opt for AL and ML. AL or ML.
There is no, what is AL?
AI, sir.
AI, sorry, AI.
Okay, so AL, I would say don't take AL. They are trying to take money from you. If somebody says, give me 1 lakh and I'll teach you AL, say goodbye. So if AI, ML, as you see, this is a very new field, very exciting field, and the applications are limitless, right? Whether we like it or not, we'll be doing ML for 10 years, right? And it is still in an infant phase, but you will need good mathematics for you to, you need to have that interest to get your hands dirty, to bend your knees and get into the mathematics of it, right? We don't want to be just, you don't want to take that to say recognize dogs and cats, which is fine, but what type of research I want to do in this area. So I just mentioned, we can't recognize children how they speak fast. How can I help blind people, deaf people? Those are very hard problems, and that can make, ML can bring productivity to all citizens of the country. Right? So you need to have that, and I think ML will be a great choice to go ahead with it. Even software engineering will have to do ML, right? So that is my opinion. Okay, but you have seen whatever you have seen. So read more on it. Even if you take computer science, does not mean you don't have to do it. Right? You can take computer science, learn about algorithms. Computer science is also very great. I mean, especially the data structures and algorithms that you learn in computer science, extremely useful for ML, right? At the same time, there is always material going on. There is always research going on for ML. Start reading on the papers. Then you can. There is nothing to prevent you from doing both. Right? Did that help?
Thank you, sir.
Sir, thank you for enlightening by this knowledge. So you explained us in a way that everyone can understand what is machine learning, irrespective of branch. And uh, you also explained the technical terms in a very understandable way with through examples. So thank you, sir.
Thank you. It was a pleasure.
So you can conclude through a prayer.
प्रियतां पुण्डरीकाक्षः सर्वयज्ञेश्वरो हरि तस्मिन् सृष्टे जगत्कृष्णं प्रीणिते प्रीणितं जगत् हरि ओं तत्सत्